Today, I'd like to talk about empty category detection using path features and distributed case frames. My name is Shunsuke Takeno. As an introduction, do you know empty categories? Empty categories are phonetically null elements such as the dropped pronoun and traces. Empty category detection is a fundamental process for pro-dropped languages, especially such as Japanese and Chinese. As example, I show the sentences between the English and Japanese sentence. As shown in this figure, there are null elements between Japanese and English. Between Japanese and English. In English sentence, in English sentence, aligned null elements such as a dropped pronoun, and also who in English sentence aligned the NP traces. There are many empty categories in pro-dropped languages. As Chan Guild reported it, recovering empty categories improves the accuracies of practical NLP tasks such as machine translation. I do the empty category detection. This problem, empty categories represent the partial information of a syntax structure. The problem is formalized as a classification problem by Shine et al. In 2013. Empty categories are encoded as a label with its position and function. We show the probability model like this, and the image is like this. We classify the inflectional nodes called IP into the whether have empty categories or not, such this. Empty categories encoded with its grammatical function label, like a subject. In these sentences, there are two empty categories, pro and traces. In this figure, and the top node IP mat on the top node are classified as a pro and subject. This means this phrase lacks subjective pronouns. And on the next, this node IP rel and lacks a traces subject. This means there is an NP trace. In these phrases, musume moves from this node to upper nodes like this. To solve this problem, we propose the two features, path features and distributed case frames. I'll explain the first path features as first. Path features are a sequence of the non-terminal labels to the root, and we combine these features and with the following three features: child features, issue features, and head features. Child features is a labels of children nodes. If I focus this node IP rel, the child nodes are VB and VB0 and AXD. And next, issue features are each features a set of empty categories in the ancestor IP nodes. In this figure, each features is this ancestor node of empty categories of these ancestor nodes. So, pro with subjective pronoun is each features. So, and finally, head features is a lexical head of the node. In this figure, the lexical head is meaning the runaway, is the head features. So we combined these three features and path features as a empty category detection features. So path features is for example, path features in this node, at this node, path features are IP rail and NP, IP rail NP and PP, and IP mat is one of the path features. So and we get the power combination path features and child features. So we can get the informative structure features. So this is a result of our experimentation on aberration test on the path features and the combination of path features and these three features. So the result shows the combination between path features and child feature is the most effective feature. So this result indicates each detection highly depends on the syntactic information and can only use the in other words, we can only use the syntactic information which only using the syntactic information we can solve the empty category detection at extent. So this feature is a syntactic information. We introduce the another features as it is a distributed case frames. So case frame lexicon would be useful for empty category detection, but case frame lexicon is not always readily available. So to solve this problem, we can propose distributed case frames. This method can be implemented easily and rival case frame lexicon. So we prepared this method prepares queries as this query for targets and words. At first, we can get the original word embedding from such as a word2vex or globe model. So next, we can prepare the queries for the targets and words. So in this in our research, the targets are predicate head word. It's like ED, and the queries are Japanese cases. So such like or because in Japanese is a case marking languages. So the such production with query and Japanese cases are represents a grammatical function. So we product query with query and targets with the queries. So we can get the such these distribution. They can be interpreted as a co-occurrence distribution. So and finally we normalize these distribution. So these distribution these process equivalent to verb subcategorization. So we can get these and this distribution informative to empty category diction. The experiment shows that as an experiment we compared with case frame lexicon and our method. So we encoded the case frame lexicon in 3 different feature ways, this, set, and B. So the result shows our proposed method is called DCHave, and rivals are these case frame lexicon. So as our conclusions, we conclude the distributed case frames can approximate the case frame lexicon. So as a whole, we use these 2 features, and our model performs the other effective problems. So we compared as a baselines. We prepared the 3 baselines and pattern match approach and described in Johnson 2002, and in Chinese state of the art method Shan et al. 2013, and the rule-based method. As a result shows, our proposed method performs each baselines. So we achieve the high accuracy for the golden path. But for the system path, it is blue bars. The accuracy is dropped significantly from system path to changing from system path, golden path to system path. So this is indicate the post-process approach highly depends on the accuracy of the parser. So as conclusion, we solved to improve this problem. We should develop the method. Issue diction and parsing should be solved jointly. So thank you for listening. That's all.